Hi guys, welcome back. Now in the previous video we discussed about how the revenue curves are made and how revenue behaves in perfect markets. In this video we are discussing how revenue behaves and how will we draw the revenue curves when the markets are imperfect. But first let's see what exactly are imperfect markets. So first of all guys, imperfect markets are basically the opposite of perfect competition, right? And it has a certain characteristics. Imperfect markets have certain features such as there are few buyers and sellers, and firms have control over the market. They have market power, right? They have market influence, while the individual firms in perfect competition did not have that. Now imperfect markets we will study properly when we will study market structures. This is just I'm going to be just quickly touching upon, and then I'll move forward to the revenue curve. So basically, like I said, in imperfect markets there are few buyers and sellers. Then the goods are non-homogeneous, they are differentiated, unlike in perfect competition where they were identical. And then firms are basically price makers, right? They decide their own price. And again, this imperfect information, and also there are high barriers to entry. So you need to understand that whenever the firms are in an imperfect market, whenever a firm has a relatively large share of the market, right? It has market dominance or market power. It will always face a downward sloping demand curve. Like unlike in perfect competition, we had a horizontal demand curve because the firms did not have market power. They were insignificant in terms of the market composition and the market size. Each firm was insignificant as compared to the total market. But in imperfect markets, an individual firm has a relatively larger share in the market, and it will always face a downward sloping demand curve, right? And when you say that, so you need to understand what a downward sloping demand curve actually means. What sort of behavior are we trying to show here? Because you need to understand that when the demand curve is downward sloping, that has an impact that will significantly have an impact on how the potential revenues of a firms are made, right? And how that will ultimately impact the marginal and the average revenues. Because when you have a downward sloping demand curve, you reduce the price, the quantity demanded goes up, and then you increase the price, the quantity demanded goes down, and that has an impact on the potential revenues, both total revenues and average and marginal revenues, right? So it simply means that if you want to sell more, it must lower the price, and if it wants to raise the price, then obviously it will have to accept the decline in sales. So we could say that firms in imperfect markets, I mean the firms that exist in the imperfect markets that have market power, they are governed by the law of demand. That's what you could write in your answer, right? Now let's talk about what average revenue is. We've already seen in the previous video as well that average revenue is always equals to price, right? So average revenue is your price. The value of average revenue at an output, right, would always equal to the price. Okay, so and price, and we know that when you if you want to increase quantity demanded, which means that if you want to increase your sales, you need to reduce your price, right? So since the price is going down and average revenue is your price, so average revenue is falling as the output is rising. So over the range of output, as you increase your output, as you sell more output, definitely your average revenue will go down. So which means that firms in the imperfect markets, they have falling average revenues, and then their average revenue curve will slope downwards, right? So and we'll see that the average revenue curve is also the demand curve. We also saw that in the previous video as well. But you see, because in imperfect markets, let's say monopoly is an example of an imperfect market, and a monopoly firm, we know that it is the only firm in the industry, right? And so you see, when we're talking about a monopoly firm, because that's an example of imperfect markets, there is we won't make the distinction between the market demand curve and the demand curve that is faced by a single firm. But we made that distinction in the when we were discussing about the demand curve for a perfectly competitive firm. We said that the market demand curve in a perfectly competitive market is downward sloping, while we said that the demand curve, which was your average revenue curve, was of an individual firm, which was very small in proportion to the total market size, that faces a horizontal demand curve, right? We discussed that, but we won't make that such a distinction over here, right? So there's no distinction between the market demand curve and the demand curve facing a single firm, as there is in perfect competition. Why? Because for a monopoly firm, a monopoly firm faces a negatively sloped market demand curve, right? Because monopoly is the only firm in the market, right? So when we're talking about a monopoly firm, we're saying that it faces a downward sloping market demand curve, and obviously it can set its own price. But in a perfect competition, that price was set by the market demand curve, and the market demand curve was different in shape as compared to the individual firm's demand curve, right? Now, as we come to the marginal revenue, guys, we all know what marginal revenue is, the extra revenue that is made, right, by selling an additional unit, right? So, when a firm is obviously going to face a downward sloping demand curve, which means that it will reduce the price, right? Meaning that average revenues will go down. So remember that marginal revenues will fall as well. So marginal revenue over the range of output. So as you increase your sales by reducing price, because that's the only way you're going to increase your sales. That is what the law of demand is telling us, that you need to increase your sales, you need to reduce your price. So if you have a downward, so if a firm is facing a downward sloping demand curve, so the only way to increase your sales is to reduce the price, which means average revenues will go down, right? And if average revenues are going down, and if you have a downward sloping demand curve, your marginal revenue will go down as well. So how marginal revenue behaves in a firm that is in imperfect markets is that your marginal revenues are falling. So your marginal revenue curve will also be downward sloping. The first thing is that a marginal revenue curve will be downward sloping as well, and your marginal revenue will be falling. Now there's a relationship between MR and AR, that is marginal revenue and average revenue in for a firm in an imperfect market, and that is that always remember that for any output level, right, your marginal revenue will always be less than your average revenue. And why it is, we'll see that, right? So also remember that, as far as marginal revenue is concerned, your marginal revenue, first of all, not only it can be less than average revenue, but your marginal revenue can also be zero as well, right? It's maybe, it simply means that there's no addition to total revenue made. So your marginal revenue can be zero as well, and your marginal revenue can be negative as well. We'll see all these rules. We will sort of look at the the calculations as well, right? So we'll see this now, and for that I have drawn a table here that has a few values and numbers. So you see, we have price, we have quantity, we have total revenue, we have marginal and average revenue. Now the prices are given, the quantities are given, and we can see that as the quantity is increasing from 1 to 2 to 3 to 4 and 5 and 6, we see that the prices are falling. So in order to increase the quantity that is being demanded and sold, you're obviously reducing your price. And we can also see that our total revenue is increasing from 10 to 18, and total revenue is calculated by price times quantity. So total revenue is increasing from 10 to 18, 24, 28, right? And then it reaches its maximum 30. But then we see that over this range of output, total revenue is the same, right? So when you're selling, let's say 6 units, your total revenue is not rising, right? It's still 30. So there's no additional revenue made, and that's why the MR is zero. And then we see that total revenue starts falling, right? And as far as the behavior of marginal revenue is concerned, we see that your marginal revenue, we can calculate marginal revenue simply by calculating the change in total revenue, or just dividing total revenue by the change in output. The change in total revenue divided by change in output, and the change in output is just 1, so the change in total revenue will be equal to the marginal revenue. So we can input these values: 10, 8. Total revenue rises from 18 to 24. So when you sell 3 units, you make an additional revenue of 6, and when you sell 4 units this time, maybe the next day you make additional revenue 4, and let's say on the 5th day, let's say you end up selling 5 units, let's say, so you make additional revenues of $2, and then on the 6th day you end up selling 30 units, and you didn't make any additional revenue because on the 5th day as well you ended up selling 30 you on the 6th day you make an additional revenue of 0 because you make a revenue of $30, and on the 5th day as well you ended up making a revenue of $30. So on the both days, right, on day 6 and day 5, you ended up making $30 because on day 5 you sold 5 units, and although on day 6 you sold 6 units, but still you ended up making the same revenue, right? So which sort of tells us the behavior of total revenue, that there would come a point over the range of output where total revenue curve will become constant. It will become completely flat. That indicates that over that range of output, total revenue is going to be the same. It's constant. It won't increase. Even though you're selling more, but still it won't increase. So you're selling 5 units to 6 units, and now you're selling 6 units, still it's not increasing, right? So That's how it behaves, right? And then when you end up selling 7 units and then 8 units, you see that even though you're selling more units, your total revenue is falling from 30 to 28 and 24 and then 18. Now you would be wondering that why is that? Why is my total revenue going down when I am selling more, right? I should my and then why was my total revenue initially increasing when I was selling when I was selling more from 1 to 2 to 2 to 3 and 3 to 4, my total revenue was rising. But why is that? On a very high levels of output beyond 6 units, in this range of output my total revenue is falling, while in this range of output my total revenue was rising. Why is that? So obviously this has to do with elasticity of demand, and we'll see that in a separate video. That's not the purpose of this video. There will be another video after this. We'll see that. But just to give you a sort of a brief overview, that we know that the elasticity of demand varies along the demand curve. It's elastic, and then towards the end it's inelastic, and it's unitary elastic somewhere in the center, right? And if that is so, if that rule follows and that rule applies, it simply means we know that if the demand is elastic, if the demand is elastic over a range of output, then in that range of output, if you reduce the price, your total revenue goes up, because when P goes down, price goes down, total revenue goes up if the demand is elastic. And if in a range of output, let's say from 7 to 10, the demand is inelastic, and if you reduce the price in that range, your total revenue will go down, because these rules we've already studied before as well. If the price goes down, if your demand is inelastic, your total revenue will go down, right? So it's the same logics being applied, but we'll see that in the next video, not in this video. So as far as your marginal revenue is concerned, you see that your marginal revenue is falling, and then it touches zero. It becomes zero, and then it becomes negative. So your marginal revenue initially will be positive, then it will become zero, and then it will become negative. So guys, marginal revenue initially will be positive, it will be falling, positive, and then falling, and then it will become zero, and then it will become negative. As far as your average revenue is concerned, we know that you don't need to calculate average revenue by dividing total revenue with price. That's the most stupid thing that you will do, because we know that average revenue is price. So just put the value of the price here, 10, 9, 8, 7, right? So on and so forth. Now diagrammatically, if we were to draw this, first of all, we could see that average revenue is at, so 2-3 things I want you to pay attention over here. First of all, you start from the y-axis, you draw a downward sloping average revenue curve, which is also your demand curve, right? And why is that? I'll tell you as well. And so this is your average revenue curve, downward sloping, right? And then why is it downward sloping? It's downward sloping because as you're increasing your output, your average revenue is falling, right? We know that your average revenue is falling because we can see that. We can see from the table as well that your average revenue value is going down as you're increasing output, because average revenue is price. So, right? And since in order to increase more output, you need to reduce your price. So that is why your average revenues will fall, right? Understood? So, so, so basically, and then secondly, guys, let's come to marginal revenue. So when you're drawing the marginal revenue curve, you start the marginal revenue curve from the same point where you start the average revenue curve, from your vertical axis. So both marginal and average revenue will start from the same point, from the same intercept, y-intercept, right? And then you see that your marginal revenue curve is downward sloping as well, because of, right? And so when you're drawing your marginal revenue curves, you know that your marginal revenue curve is downward sloping because marginal revenue is going down from 10 to 8, 6, 4, 2. We know that. But the thing that we also need to understand is that your marginal revenue curve becomes zero when you sell, your marginal revenue is zero when you sell 6 units. So when you're selling 6 units, there's no additional revenue made, right? So which means that your marginal revenue is zero. There's no addition to total revenue. So you see, and then it becomes negative. So let's say when you're selling 7 units, let's say when you end up selling 7 units over here, your marginal revenue is negative, and the value should be, how much is your marginal revenue at 7 units? When you're selling 7 units, your marginal revenue is -2, right? So that's how you make it. You don't need to put in these values in the exam. This is just for your own understanding. You just need to draw these curves and know the economic concepts behind it. So now 2-3 important things that you must know. First of all, you need to start your marginal revenue curve from your average revenue curve, where you're starting the average revenue curve from the same intercept. Secondly, when you're drawing your marginal revenue curve, for example, you draw your average revenue curve like this, right? So you're not supposed to touch your average revenue curve on the horizontal axis, because average revenue is price, and price can never be zero. If you touch it on the horizontal axis, it means that your price is zero, and price can never be zero. And your average revenue curve can also not become negative because price can never be negative. So these are the small things that you must be aware of. So your average revenue curve is going like this, downward sloping, but don't touch it from to the horizontal axis. Secondly, a marginal revenue curve starts from the same point and then it goes down, right? And then it touches the x-axis, meaning marginal revenue 0, and then it becomes negative. Now, the most important part, if this is your average revenue, then you're supposed to draw your marginal revenue curve somewhere in the center, right? Because your marginal revenue is downward sloping and it's falling, but it's steeper than average revenue. In fact, mathematically, it is twice as steeper. We know that this line, average revenue line, is linear. It has a certain slope, right? But so is a marginal revenue curve a linear line as well. So this also has a certain slope. But you need to understand that marginal revenue, since the fall in marginal revenue is faster than the average revenue fall. So, the marginal revenue, it follows that the marginal revenue will have a steeper slope. And for that reason, you need to make sure that you draw the line for the marginal revenue curve as somewhere that has as a line that has a steeper slope. So just draw it somewhere in the middle, right? Like this. Do not draw it like this. So if this is your average revenue, let's say, just a second, this is your average revenue, let's say, do not draw the marginal revenue curve as like this, right? This is not indicating steeper slope. And in fact, mathematically, you know what? If you're saying that this is your average revenue curve, then the marginal revenue curve has to be in the center. Remember that, because there's a mathematical reason. It has to be equidistant from the vertical axis and equidistant from the average revenue curve as well. So just make sure that you draw it like this, right? Do not draw it like this. Do not draw it like this, okay? So now, I hope what I was trying to explain, I have covered these points. So average revenue, again, let's see what I've written here. Average revenue curve starts from high, as in from a higher point, as in this point, right? But then decreases and slopes downwards. The average revenue is our demand curve. We also know that the average revenue curve is our demand curve. And marginal revenue is starting at the same point on the same intercept of the average revenue curve, and marginal revenue is decreasing as well, and also has a downward sloping. Marginal revenue curve is also downward sloping. But the thing is that marginal revenue is decreasing at a faster rate than the average revenue. The decline in marginal revenue is faster than the decline in average revenue. Now, if you were to ask me how fast is it, I'll say twice as fast, and I'll explain it to you as well. Now, moving forward to the total revenue curve, if you were to plot the total revenue curve, you plot the total revenue curve you start your revenue from origin, because at 0 units, your revenue is 0, you're not selling anything. And then the total revenue curve will be drawn like this. Okay, it is increasing and then it becomes constant and then it becomes decreasing. So your total revenue would be the maximum. It will hit its peak when your marginal revenue is 0, right? At 6 units. We know that at 6 units, let's say, when you're selling 6 units, the total revenue is maximum at 30. Okay, and then after 6 units, when you ended up selling the next day, let's say 7 units, your total revenue fell to 28. So there's a decline from this point. Okay, so your total revenue is maximum and your marginal revenue is 0. All right, so that's how you draw your total revenue curve. And remember that, for a price taking firm, that in perfect competition, we knew that total revenue curve was a linear upward sloping straight line, but that's not the case for a firm in imperfect markets. And that is why, remember, I told you that the reason why we are distinguishing perfect and imperfect markets while studying revenue is because revenue behaves differently in perfect and imperfect markets, right? So total revenue is rising as output rises. But remember, when your total revenue is rising as your output is rising, each time your total revenue is rising on this entire range of output, right? When you say that your total revenue is rising, let's say, up till it touches its maximum point, if you observe the behavior of this curve and if you sort of observe the slope of this curve, each time it is increasing, the slope is getting flatter. You see how flatter it is turning. And when the slope is turning, it's getting flatter, right? And if it's getting flatter, it means the slope is falling. And what is the slope of total revenue? The slope of total revenue is your marginal revenue, right? So if you calculate the slope between these 2 points, it will be equal to your marginal revenue. And if the slope is falling, if the slope of total revenue is falling, it means that your marginal revenue is falling. So, and that is the reason why your total revenue is increasing at a decreasing rate, at a slower rate, because your marginal revenue is falling. So it is rising at a decreasing rate. Your total revenue is rising at a decreasing rate. It will hit its peak and then it starts to decrease. But the thing is that as long as your marginal revenue is positive, remember this is important. As long as your marginal revenue is positive, which means so in and again I've written hence demand is price elastic, but I will not explain this because it will be explained in the next video. As long as MR is positive, total revenue will rise as output rises. Understood? As long as MR is positive, TR will rise as output rises, and once your MR becomes negative, total revenue will fall because it will pull your total revenue down. So total revenue is peaking when your MR is zero. And okay, so guys, an important thing that I need to also tell you is that I've written here as well. Let's see this what I've written. So since the MR is basically your change in total revenue resulting from the sale of one more unit of output, MR is positive over the range where total revenue is increasing, and it is negative where total revenue is decreasing. So in the range where total revenue is decreasing, in the range means the range of output. So in this range of output, your total revenue is decreasing. And in this range of output, we can see your total MR is negative as well. Right? In this range of output, your total revenue is increasing. And in this range, in the same range of output, we can see your MR is positive. Although it's decreasing, but MR is positive. Now, another important thing that you need to understand is the relation between MR and AR, right? For a firm in for a firm in imperfect markets, right? Such as, let's say, a monopoly. So, guys, when the firm is a monopoly and you say that average, so first of all, we know that average revenue is falling. Second of all, we also know that marginal revenue is falling. So, guys, the important thing that you need to know is that, first of all, at any point, if you take any point, let's say Q1. So, at an output of Q1, if this is your MR, right? If this is your MR, then your average revenue would be more than your marginal revenue, right? So MR is always going to be less than AR. So that's a property, right? MR will always be less than AR for a firm that is making revenues under imperfectly, in markets that are imperfect, right? So MR is less than AR. So that is what you need to know. And I'll explain it to you why as well. But moving forward, if you were to ask me that if you were to ask me that, and also I think I don't remember if I've mentioned this in this video right now or not, but since it's written here, I've made this on the slide. So let's see that I think I mentioned or not. I don't remember right now, but MR can become zero and negative. We've seen that. But average revenue cannot, because price cannot become zero or it cannot become negative, right? Anyways, so, well, I just recall that I think did mention this before. Anyways, so guys, like I said, MR is less than AR. First of all, MR is less than AR at each quantity. Let's say if we end up selling Q1 units, and let's say Q1 units could be 4 units. So let's say if we end up selling 4 units on maybe a good Sunday morning, or that could be any day, let's say day 3 or day 4. And if you end up selling 4 units on that day, then the average revenue that would be made on that day would be more than the marginal revenue that was made on that day by selling 4 units, right? That's what we're trying to explain. You must know the analysis. It's not just writing down MR is less than AR. I mean, what does it in your head? You should be very clear headed about what it means. So MR is falling, AR is falling, but MR is falling twice as steep as AR. The MR curve, the MR is falling faster or steeper than the rate at which the AR is falling. And how steep? As in twice as fast as your average revenue is falling. Well, it simply means that if average revenue is falling by $1, then marginal revenue will fall by $2, twice as fast as the average revenue, right? Twice as fast as the average revenue. If someone asks you the next time that why MR is less than AR, the simple reason is the reason why MR is less than AR is simply because the firm faces a downward sloping demand curve. And because it faces a downward sloping demand curve, then it has to reduce the price in order to sell more. And what would that mean for average revenue or marginal revenue? I'll tell you. I'll explain to you in a bit. But before that, let's see that whether marginal revenue is falling or why does marginal revenue is twice as steep as AR, or why does it falls twice as steep or twice as faster. So there are 2 reasons associated to it. First is a mathematical reason. Do we need to know the mathematical reason? The answer is no, right? But still, I would love to prove it, and probably not in this video, but maybe sometime later, I'll prove it how and why it falls twice as steep. right? But we could still live without knowing the mathematical reason, so it's cool, we're cool. However, there is a logical or intuitive reason attached to it, and explain that in this video. But before that, let's see whether MR is falling two times faster than average revenue or not. So for example, if you end up selling from one unit, you end up selling 2 units. Let's say on day one you were selling a unit, and the next morning you ended up selling 2 units, and you did end up selling 2 units because you faced a downward sloping demand curve, and that was only possible because you reduced your price. That is what the downward sloping demand curve means, that you need to reduce your price to increase output sold or demanded, right? So the average revenue went down by $1, but you see that the marginal revenue went down by $2. Similarly, the next day you ended up selling 3 units on day three, and then the average revenue went down by $1, but then the marginal revenue went down by $2. Then on day 4, you ended up selling 4 units. The average revenue went down by $1. The marginal revenue again went down by $2. On day 5 as well, AR went down by $1, while the marginal revenue went down by $2. So what we see here, again over here as well, the average revenue went down by $1 and the marginal revenue went down by $2. Now, what sort of a behavior are we studying over here? What sort of a relationship that is being established between MR and AR? Come on, guys, throw it up in the comments, right? So the simple relationship between MR and AR is that MR is falling and AR is falling. That we're cool with that. But then we also see that MR is falling twice as faster as average revenue, right? And that is why it's important that you make and that is exactly why I told you to make the average revenue curve as in the marginal revenue curve like this, right? I mean, you have to make sure that you're making it steeper. And you also have to make sure that, the distance between from MR to AR versus the distance between MR to your vertical axis is the same, right? But do not make it like this. I mean, this is the wrong way to make it. Also, don't make your average revenue curve like this, and I've told you the reason why. Anyways, let's see why does MR falls faster than average revenue. Let's see that why is MR falling more than average revenue? Why is it that, let's say, on day 3 our average revenue is 8 and our marginal revenue is 6? And why is it that on day 2 our average revenue is 9 while marginal revenue is 8? And then why is marginal revenue less than average revenue? I mean, why the addition to revenue is less than the average revenue on that day? Why is that? And because of that, we see that, each time you end up selling more, your average revenue will obviously decline, since price is declining and price is average revenue. So is our marginal revenue is declining, but then it's declining. We already saw mathematically it's declining twice as faster. So what is the logical or intuitive reason behind it? You see, the thing is that I'll explain that through 2 examples. First of all, let's see. I've taken these 2 bars and then 3 bars. These are chocolate bars, let's say. So let's say on day 1, right? Now these values are not, I'm not relating it to the values in the table. This is just separate. So let's say on day 1, you end up selling 2 chocolate bars, and each chocolate bar is for $9. So what is the average revenue on day 1? Obviously it's $9 because AR equals to price. And what is the total revenue on that day? It's $18 because you're selling 2 chocolates. On day 2, the next day, you end up selling 3 chocolates. But you knew that, in order to sell 3 chocolates, you need to probably reduce the price. So you reduce the price from $9 to $8. Cool. Now, the total revenue shoots up from 18, it shoots up to 24, and you see that the addition to total revenue is $6. Now, what we are saying is that on day 2, the addition to revenue is $6, while the addition to revenue is $6. That is the marginal revenue, but the average revenue on day 2 is $8. But why is why is the marginal revenue being less than average revenue? Why is the addition to revenue less than what the average is, right? And you see, you need to understand this. Why? And then it simply also means that, the marginal revenue falls faster than the average revenue. So two things. Why is average revenue less than, why is marginal revenue less than average revenue? And why is marginal revenue falling faster than average revenue? We need to see both these things. And the simple reason is that, you need to understand that what the average revenue on day 2 is. The average revenue on day 2 is $8. But you see, if I were to ask you how much revenue did you gain on the second day, you will say that we gained $8 because we ended up selling one more unit. That is the third chocolate bar. So when you sold it for $8, so we gained $8, right? But then the point is that although we gained $8, but then we also lost $2, because you need to understand this. I mean, on day two, we ended up selling three chocolates, right? Three chocolates. But three chocolates means two chocolate plus another chocolate, right? So if we, but again, I'll repeat, three chocolate means two chocolate and another chocolate. But these two chocolates were also sold on the first day as well. And they were sold at a higher price, that is $9. So if you're selling three chocolates on day two, and out of three chocolates, two chocolates, the number two chocolates were also sold on day one as well, right? So on day three you're just selling one more. I mean, on day three you're selling three chocolates, but if you compare it with on day two you're selling three chocolates, but if you compare it with day one, you are selling an additional chocolate this time on day two. But and that's cool. But the thing is that, you see, in order to sell another chocolate, you have reduced the price. That is, in order to sell the third chocolate, you said that, oh, you want to make more chocolate, you want to sell more chocolates right now, let's reduce the price. And you sold the third chocolate for $8. But then it's not only the third chocolate that you sold for $8. Also, the first two chocolates sold on that second day were also sold for $8. However, the first two chocolates that were sold for $8, I mean, these two, the same two chocolates, as in the number the same, as in the same number of chocolates, as in two chocolates, were also sold on day one as well. But then they were sold at a higher price. You ended up selling two chocolates on day one at a higher price, and then you ended up selling two plus one chocolates on the second day at a lower price, and all three chocolates were sold at $8. So you see, the problem is that although you've gained $8 by selling the third chocolate, but you've also lost $2. Why? Because the first chocolate that you ended up selling on day two, you sold it for $8, but on day one, the same chocolate was sold for $9, right? So you're losing $1 as revenue here. Similarly, the second chocolate was also sold for $8, and the second chocolate on day one was sold for $9, right? So you're losing another a dollar on your selling your second chocolate. However, the third chocolate, you're gaining $8 by selling it for $8, right? But technically, theoretically, what you need to write is that when you're reducing the price, right? When you're reducing the price to sell more chocolates, the price is not only reduced. The reason why, so you see, when you reduce the price, when the price goes down, average revenue goes down. So average revenue was 9, and now the average revenue is 8. So average revenue falls from 9 to 8. It falls by $1, right? But the marginal revenue will fall more, and the reason why marginal revenue will fall more on the second day is because, you see, average revenue is although falling by $1, but then your marginal revenue is going to fall more because there would be a loss on because you have reduced the price not only on the additional chocolates that you're selling on that day, which is, let's say, another third chocolate, but you've also reduced the price for the previous chocolates that you could have potentially sold at a much higher price. In fact, you did sell them at a higher price the previous day, right? So obviously that would result. So each time you're selling, each chocolate that you're selling on the next day, you're selling it at a lower price. So the loss of additional revenue is 2. I mean, although you're gaining 8, but then you're losing 2 as well, right? So that makes your the value of your marginal revenue 6, which is sort of less than your average revenue, right? So it's actually the reason why your marginal revenue is less than your average revenue. The reason is that there's a loss of revenue. There's a loss of revenue on the previous units attached to it as well. I mean, those units that could potentially be sold at a higher price, in fact, they were on the previous day, are now being sold at a lower price. So that loss brings your marginal revenue down, actually. In fact, it reduces it, less to an extent that your MR becomes less than AR. Cool, guys? So that's the theoretical explanation to it. Now there is a graphical explanation. I mean, you need to also you need to know how to show this in a graph. So in a graph, if the price is going down, the quantity is going up. So this blue shaded area is representing the reduction in revenue, while the red shaded area is representing the addition in revenue. And this is pretty simple. You see, let's say if this is your demand curve like this, don't touch it to the x-axis. If this is your demand curve and the price goes down from, let's say, P1 to P2, the quantity goes up from Q1 to Q2, and you see, let's say, so your initial revenue, when the price was P1, your revenue must be A plus B, this entire P times Q1, P1 times Q1, A plus B would be, so your old revenue would be A plus B, while your new revenue after reducing the price to P2 must be B plus C, this entire region, right? It must be B plus, your new revenue must be B plus C, right? So, so B, so this variable B and this variable B. So this B is the same in the old and the new revenue. So what have you gained then? You have gained actually C, right? So this area is representing the gain in revenue. But how much have you lost? You've lost A because A doesn't exist in the new revenue. So you've lost this part while you have gained C. Similarly, this is the same that we have shown over here, right? Reduction in revenue is the blue area while addition to revenue is the gain, right? And I've written this as well that, and this is the reason why average revenue is less. Remember, this is the theoretical explanation to why average revenue is less than marginal revenue. And not only that, each time you reduce the price, listen to this very carefully, each time you reduce the price and you end up selling more, the average revenue, the marginal revenue falls faster than your average revenue. Okay? So because the demand curve has a negative slope, that's the reason you need to reduce the price. Step 1. Because you need to reduce your price, and each time you need to reduce your price to sell more, your marginal revenue is not only less than your average revenue. In fact, each time you reduce the price to end up selling more, it falls faster than your average revenue. So MR is less than your price, that is AR. So a reduction in price from P1 to P2 increases your sales by, let's say, 1 unit. Let's say this is increasing by 1 unit, for example, hypothetically, from Q1 to Q2. So the revenue that you have made from the extra units sold is shown in the red area, right? It is the revenue that you have made from the extra units sold is in the red area, which is if you see it mathematically, I mean, although this was another example, but this should be this value, the value 8. I mean, this value is not applicable over here, but just to show you that, because 8 was the extra revenue that we were making, right, by selling extra units, right? So the revenue sold from the extra units sold is shown in the red area. So this area is representing all the revenue by selling additional units, the gain in revenue. But to sell this, the problem is that to sell these extra units, that is in order to sell the third unit, like I said, in order to sell the third unit, you need to reduce the price. But you don't need to reduce the price on the third unit only. It's not that you said that you will sell the first 2 units at $9 and the third at $8. No, this was actually sold at $8 as well. And that is what makes the marginal revenue go faster downwards, right? And that is exactly what makes your marginal revenue not only less than AR, but each time you reduce the price, the MR falls faster than AR. But to sell this extra unit, it is necessary to reduce the price on each of the Q1 units previously sold. That is on each of these units that were previously sold. So putting those above values in this graphical example, if this is 2 units and this is 3 units and this is Q1 units is equal to 2 units. So if you are reducing the price, then you are reducing the price on the previous 2 units as well. Let's say on the previous 2 chocolate bars as well, right? So the loss in revenue is shown by the blue area, and the marginal revenue of the extra unit, guys, the marginal revenue of the extra unit is equal to the difference between the 2 areas. So the difference between these red and the blue area, the difference between the red and the blue area, for example, the gain of 8, the loss of -2, so MR is 6. Okay, guys, and remember that for a price taking firm, if in a perfect competition, we know that the MR is equal to the AR. But for a firm that is a price maker in imperfect markets, the MR is less than the AR. And the reason is why MR is less than AR, I'm going to repeat it again and again, right? The reason is that the price making firm is facing a downward sloping demand curve. It has to reduce the market price in order to increase its sales. But then the market price is not only reduced on the additional units that you're selling, but all on the previous units as well. That makes your marginal revenue below your average revenue or less than your average revenue. And each time you reduce your price to sell more, your MR falls, but it falls faster than your average revenue, right? So I think I've covered everything. One last thing, why is average revenue also the demand curve? Let's quickly see that before we wrap it up. Our demand curve tracks the price the firm will set for the quantity, which simply means that at what price you're going to sell what. So the demand curve is tracking that. Okay, fine. You need to sell 3 units, reduce the price, 4 units, further reduce, 5 units, further reduce. That they will choose to produce and sell. So for instance, if the firm wants to sell Q1 units, they will set a price P1. Like we saw on the diagram. If they want to set a quantity of Q2, they know they will now sell it for P2, which is less. So, and we know that the thing is that price, as we saw before as well, that the price is equal to average revenue. So if the demand curve tracks, now listen to this very good, the demand curve tracks the quantity to price, and we know that average revenue is price, As we saw before, that price is equal to average revenue. So it follows that the demand curve not only tracks the price to various levels of quantity, it follows that demand curve not only tracks the price to various levels of quantity, but it also tracks the average revenues for various levels of quantity. So that is why the demand curve is equal to the average revenue curve. It's quite simple. Nothing as such, nothing complicated. So we've covered the logical explanations, we've covered the diagrams. I have explained why TR is going up and then it's going down, and MR being less than AR and the slopes as well. So I think I've pretty much covered everything in this video. Okay, so the next video should be on the relation between PAD and revenues. So I'll see you in that video. Thank you so much for watching, and until then, take care.